Our lesson today is about trends in periodic table. And when we say trends, it is the general direction in something developing. So, first, let us recall our periodic table. We learned that the elements in periodic table are arranged according to columns. We have the group, and periods. And we learned that the period number corresponds to the number of energy levels, right? This period 1 has 1 energy level, period 2 has 2 energy levels, period 3 has 3 energy levels, period 4 has 4 energy levels. So let us have an example. Let's have the group 8A. Okay, the group 8A, first is helium, and helium has 1 energy level, followed by neon, 2 energy levels, argon with 3 energy levels, and krypton with 4 energy levels, and xenon with 5 energy levels. So as you can see, from top to bottom, in a given period, as the energy level increases, the size increases. That is why our trend in size is this, that from top to bottom, size increases, and from left to right, size decreases. So why is it that from left to right, the size decreases? Because of this explanation that the period trends in atomic size is because across a period, the electrons are added to the same energy level. Remember, the energy level is constant, and there is the increasing nuclear charge pulling the electrons closer to the nucleus. Thus, the atomic size decreases. As you can see, in a given period, the energy level remains the same, but there is an increasing number of electrons, and the effect of that increasing electrons is the increasing nuclear charge, which pulls the electrons closer to the nucleus. So, as the electrons are being added on the same period, the smaller the size because of the nuclear charge increasing, pulling effect. Okay? So, we generalize it. The size decreases from left to right and increases from top to bottom. So, where do we see the biggest size? At the bottom. And where do we see the smallest size? On the left. I will share with you one technique that I applied when I was a student. I create acronyms. So, this acronym like BLB. B stands for bottom, L stands for left, and B stands for big. So, it means where do I find the big size? At the bottom and left. So, I always remember bottom, left, big, BLB. So, the opposite is bottom is top, left is right, and smaller for big. Okay? So, I hope you will also apply the same so that you won't forget. So, let's go now to ionization energy. What about ionization energy trend? To be able to understand this, we have to understand first the meaning of ionization energy. When we say ionization energy, it is the amount of energy required to remove one electron from an atom. And if it is to remove, it makes sense that if this is the positive nucleus, this electron is very strongly attracted to this nucleus, right? Compared with the electrons far from the nucleus. So, highest energy, ionization energy is needed to remove this electron, right? This one, lower energy. So, what is our trend? From top to bottom, ionization energy decreases because the size increases. BLB, bottom, big. so it decreases. And ionization energy increases because the smallest size atom are on the right. Okay, are on the right. So that's ionization energy. So next we go to metallic character trend. But before we study that, let us have the classification of the three classification of elements in the periodic table. We have metals, non-metals, and metalloids. So I colored the metals all pink and the non-metals yellow, including hydrogen, and of course the metalloids orange. So the ones separating the metals from the non-metals are the metalloids. And of course, hydrogen here is a non-metal. So it makes sense that the metallic character decreases from left to right because the direction is going to the non-metal group, right? It makes sense. So from top to bottom, the metallic character increases. It is also the same as the reactivity. From top to bottom, reactivity increases. That is why we say in group 1A, the most reactive metal is francium. Francium. Okay, so that is the trend in metallic character. Let us have electronegativity. But first, we have to define what is electronegativity. Electronegativity, as we learned in our previous lesson, it is the ability of an atom, of an element to attract electrons when the atom is in a compound. And we learned in our previous lesson that the highest electronegative value are belonging to these non-metals, especially F, fluorine. It is the most electronegative. Okay, and the trend is from top to bottom decreases. And of course, from left to right increases. And it makes sense because, again, the non-metals are the highest in electronegativity. So, increases, decreases, electronegativity. Okay? So, make your own acronym so you won't forget. I have already taught you BLB. Now, I want to introduce to you the name of the four group. We have group 1A is named as alkali metals. Group 2A, alkaline earth metals. And these are the transition metals. And the group 7A, we name it as halogens. And of course, the group 8A, the noble gases. Okay?